1, or chemistry, 2.5, 2.6. 1, you could either say significant figures or significant digits. They're the same thing. Different books, different scientists like to call them different things. Up to you what you call them. 2 is to round. 3 is the place is what matters. For adding and subtracting, everything's got to get cut off in the same place so you can add it and subtract it. For 4, it's the significant figures or the significant digits, or if you want a short way to say it, the sig figs is a way to shorten that word. 5 is a thing called exact numbers, and I'll explain exact numbers, I guess now. Something like there's 12 inches in a foot. You can consider that to be an exact number. All of the other numbers that you'll hit in science, if they've been measured, there's like a little bit of uncertainty. If a scientist just says 12, that's a 2-digit answer, 2 significant digits, but the last digit is always uncertain. So that's them saying 12, probably, but we won't rule out 11, and we won't rule out 13. But we'll just say 12, that's what we think, but we're leaving wiggle room of 1. When you're told there's 12 inches in a foot, that 12 is an exact number. That's like 12.0000000000000 forever O's. There's no wiggle room. It is on the money, 12. Everything you've ever done in math, every math number is basically to you an exact number. There's not like any, maybe they measured this a little bit wrong. But anytime you're measuring something, there comes a point where you're going to have to basically guess. If I grab my meter stick and I put this paper or whatever on there, this is right now, I'm on the centimeter side here, so I'm at like 56 and some change. I'm very sure I'm past the 6th line. So I could confidently say this is 56.6, and then I've got to guess 2. 56.62. I'm not sure about that 2. That's just my best guess of what I'm looking at on the stick. There's always a point where you're just like guessing. I don't know what your bathroom scale is like. It's possible you stand on your bathroom scale in the morning and it says like 126, and maybe that's all it says. You might be 125.9. You might be 126.2. Like, that's their best guess. If your scale says in your bathroom in the morning, 126.4, you might be 126.5 or 3, like with some more digits in there. There's always a guess. Any measuring tool, there's a guess at the end of the measurement. And that's what significant figures are trying to communicate. Question about the 5, first 5.
What was 3?
3 was place values.
What was 4?
4 is significant digits.
And 1?
1 was significant digits.
So 2, would you take to just use the first 3 digits?
I'm gonna look and see what the book had to say about some things. I'm feeling that's more of a no. I'm gonna go no on that. Something on first 5. Then it's our oldies. Measurement, quantity of matter, or no. Anything that has mass takes up space. 8's the quantity of matter. 9's gravitational force between an object and a planet. 10, mass is the same everywhere. 11, space, something takes up. 12, volume equals length times width times height. Density equals mass dividing by volume. 14 is sync. 15 is metric, or SI versus English based. 17, metric is used everywhere. Metric is on powers of 10. 19 is grams, meters, liters, grams per milliliter, and grams per liter. 24 is that cubic centimeters or cc's are the same as milliliters, and then I'll pause. Question about the super old time words. Sometimes as a student I would wonder, do the teachers actually know these answers, or are they always just reading off a script? I know the answers, and I have my paper to prove it. This paper has a big empty space in the middle. So if you're sitting there like, did he learn all these words, or is he just picking on me and he doesn't actually know anything? The answer is I actually know things with my paper in the middle to prove it. 25, we got Fahrenheit, we got Celsius, we got Kelvin. Fahrenheit, I'd say half a point for water freezing at 32, half a point for water boiling at 212. If they didn't say water at all, take off like half of that point, I guess. Celsius, water freezes at 0, water boils at 100. Half point per fact, I guess. If they didn't mention water again, don't kill them again, because we already took something off over that. Kelvin should mention 0 Kelvin, it should mention negative 273 degrees Celsius, and it should mention absolute 0, that's a trifecta that are all the same temperature. Then mass is balances, weight is a spring scale, or just a scale can work for me. Volume, I said name 2, because that's like a 6-point question. Is there anybody that didn't name 2 that quick wants their paper back? What is your second one going to be?
Can I do tablespoon? Or is that cheating?
What did you say for your first one?
Yeah, I have teaspoon.
I'll be kind and say I'll take it today. But we got measuring cups, we got teaspoons, we got cylinders, burrets, pipettes. It's a big club. Thermometers, almost last, ruler is last, and that's our first quiz. Something on that. Okay.
For number 3 and 4, 3 they did mock numbers before. Okay.
Anybody else anything? Let's trade up those metrics if you didn't do that yet, because nobody's going on metrics still, are you?
I didn't do it.
Didn't do it? I was behind the scale.
Okay, well.
So we'll take metric time out and let's go through the notes of significant digits. So I used to just furiously write all these notes on the board, and then people would furiously write these notes down, and then I hit a point in my life that I thought, this feels like a packet. So I just ran this off and we can just kind of read it together. So people that have been through physics, it doesn't hurt to refresh, I guess, but this will be a little bit of old news. People that never took physics, this is definitely new news. So here we go again. I briefly previewed this yesterday, but if we're going to communicate how certain a measurement is, there's a thing called significant figures that get used. So if I ever said to you 80, and I want to say 80, give or take 10, since that 8 is in the tens place, you could just write 80. That number has one significant digit, which is the 8, and the 8 is therefore not really certain. Maybe there's 70, maybe there's 90, 80 is our most likely amount, so we're just going to say 80, but since the only other digit there is a 0, that's just what it's called a place-holding 0, just to keep the 8 in the right place. That's a way a scientist could communicate 80, give or take 10. If I wanted to communicate 80, give or take 1, what I could do is write 80 and put a bar above the 0 that's in the ones place. And now that has two significant digits. The 8, which is now certain, and the 0, which is like, give or take 1 in the ones place. If I wanted to do a more precise answer, I could say 80.0. Zeros in decimal positions are considered to be significant when they're at the end like that. So what I'm communicating with 80.0 is, I think there's 80 still. All three of these stories, I think there's 80. But 80.0, I'm confident that if I'm off, I'm only off by a tenth because I stopped giving you digits in the tenths place. Question about the concept, especially our non-physics takers. Anything uncertain about what I'm saying? Yeah?
I really don't get if there's the point 0, that's supposed to be.
Okay, usually you don't write the point 0 on a number like that, and a math teacher would criticize you, like, why are you writing that point 0? That doesn't do anything for the value. A scientist doing that is doing it because that's where they lost control of their measurement. If they put 80.0, they're like, I think there's 80, and I'm confident to that tenth position. If I had like a really nice tool and I measured something to like accurately the millionth place, I would write 80.00000 until I hit a zero in the millionth place. That's how I communicate to you. I think there's 80, and I'm sure like to a millionth of a whatever inch or whatever it might be. Does that make sense?
That makes more sense.
Okay. Anybody front, question about concept? Okay, so here this goes, flip the page into actual usage. So if you see any digit other than a 0, 1 through 9 kind of digits, those are always counted as significant digits. Zeros is where it gets tricky, because sometimes you write zeros just because you have to. Okay, so like if I had $8 million, I have to write those zeros, otherwise it looks like I have $8. Okay, those kind of zeros are called placeholding zeros. Those are not significant digits. I'll come back to that in a minute. But if I want zeros to be counted, because they're meaningful to my measurement, if I want that 0 to count as a significant digit, I can put bars on them if they're in whole number positions only. So if I have a whole number position and I want that to count, I'm going to have to put a bar on it. If I have a decimal kind of number, zeros at the very, very, very right end of a decimal number are always counted as significant digits. And then if zeros just get trapped in between other significant digits, those get counted. It's maybe easier to understand it from examples than rules, so here's some examples. 348, all three of those digits are significant because they're stuff other than zeros. So that's a 3 count. Number 2, that 300 is a 2 count, the first one, because I put a bar on that middle digit, the first 0 encountered. So 300 with a bar in the second position, that has 2 significant digits. If I take the bar away, just regular 300 has only 1 significant digit, which is the 3. The zeros are just there functioning as the word placeholders that I've used a couple of times. 62.0 is a 3-digit answer because zeros at the right edge of a decimal, they count. 62.000 has 5 significant digits because zeros at the right edge like that, they count. If I just wrote 62, that only has 2. In that problem 4, I've got a bunch of stuff in the 300s. 308 has 3 because 0 in the middle gets counted. 300 plain has 1 significant digit because only the 3 counts, not the placeholders. If I put the bar on the last position, now I've got 3 again because zeros with bars count, zeros stuck in the middle of things count. 304.00 has 5 because zeros at the right end of a decimal count, zeros trapped in the middle of stuff counts, that's a fiber. And then that last one, 304, that has a 3 count because zeros in the middle get counted as being significant. Question about how I'm counting? So flip the page and you try to count. Test yourself. Here's a bunch of similar kind of questions. Do a count and tell me how many you got. If you get bored waiting, the packet copied well enough that you could just turn the page like this on a little fold and get the answer if you get bored waiting for us. So I'd say do them, fold it. Beyond the fold, there's even an explanation of what counts and what doesn't. If you got surprised, it would explain why I said what I said. But if you don't understand what I'm saying, let's verbal that out. Did anybody hit any yet that you're like, I don't get it?
I messed up on the 2 and 4.
Okay, so
But I
zeros,
realize why now.
yeah, if the zeros are to the right of the decimal point, but not located all the way to the end, those are another type of placeholders and those don't count.
Right.
So like 0.670 counts it. 0.067 doesn't count. It's just a placeholder. Without that 0, you can't you can't get to the place you need to get to without the zero helping you. Anybody on that list need more time to play the game? Okay, on the turn page where the answer is, I explain, I think, again, what I just did verbally. Zeros in decimal places only count if they're all the way to the right end or if they're enclosed or trapped between others. Zeros in whole number places only count if we cover them up with a bar or if they get enclosed. There. Then here's a skill that we'll need, is take all of these numbers on the next page and make them have 3 digits. So on some of these, you're going to round to the 3rd position. On others, you might need to put on some like decimals or zeros or something to make there be 3. But if we're trying to round to the 3rd position, just count to the 3rd position and round. But before you go too deep into that, chemistry has a rule that physics didn't. And let me look it up off my notes and make sure I positively tell you the right thing. Traditionally in math, 5s always make things round up. In chemistry, they will not do that. So if I demand that you want to round to the 10th place, traditionally in math, you'd make this be 0.5. And you make this be 0.6. The trouble is, if you do measurement after measurement after measurement, and the 5s always round you up, over time in your science career, you're going to be over measuring, because really that's dead center. And if we want to be fair, sometimes that should go up, but sometimes it should go down to like bring balance to that. So if there's a number that we're rounding to its position, and then there's a 5 and nothing else, then there's a new rule for chemistry only, which is we make stuff be even. So 0.5 does indeed round up to 0.6, but 0.4 will stay 0.4. Evens are our friend. I won't even mention the other number, and you can just remember that evens are where it's at. So if we're rounding, evens stay because of 5s. Odds go up to evens because of the 5, and that's only if it's a 5 where the number stops. So if I went back to this and it's 0.45 anything else, you would go up to the 5. It's only like dead center perfect 5s that stop that do that weird rule. This one didn't fold copy quite as well, so it gives you a little bit of the ability to fold and peek, but it's not as good of a fold as the other fold was, so sorry, I blame the copier. I could blame myself, but I don't why blame myself if I can blame something else. If you flip and you're mad, let's talk.
For the second one,
Yep.
what would that?
So we're gonna go, the 3rd position's the 4. There's a 5 there that isn't the stop of a number, it's 5 and more stuff, so go up as
Okay.
traditional rounding goes up.
Okay.
The only one that's gonna do that new weird rule is that 3rd one,
Okay.
because it's a 5
Okay.
that
I
got no
understand
help.
now.
That earlier 5 got help. There's a later one too. There's another 5 that doesn't have help when you get in the decimal zone.
So placeholder zeros don't count as numbers then?
Not for rounding purposes on this, no.
Okay.
Anybody else run into any, like, I don't get it? Does anybody need more time to cycle through that page?
Yeah.
Okay. Yeah, I'm never sure how much time to give, and it's hard to see from here what everybody's doing.
Would a zero with a line over it count?
It won't do anything for rounding, but it counts as a significant digit. So like, where are you?
This isn't on the page,
Okay.
just speculative.
All right, yeah, so if there's a bar on a 0, that counts in our significant digit counting, but it doesn't affect anything about your rounding.
They still go to the nearest whole number.
Yeah. Anybody need more time still to cycle through? Okay, so here's an adding example. Adding and subtracting, you're gonna always round stuff first. You're gonna make everything cut in the same place, and then you do your math at the end. So if we had to add up this stack of numbers, the 0.2 in the tens place is the first cutoff. It's the quickest any of the numbers cut off is in the tens place. So what you'd have to do is rebuild your stack where all the numbers got cut off in the tens place, and then add up and see what happens. That's the rule for adding and subtracting. Anybody confused about that? Then back page. Multiply or divide is the opposite order. You're going to do the mathy stuff first, and then you're going to worry about where to round. So if I had to multiply those two numbers, I would just multiply them on my calculator, get an answer like I would have as a whatever middle school student whenever you were doing that kind of multiplication. But then you do a count. 2.34 is a 3-digit number. 5.6 is a 2-digit number. So we're going to take the fewest of those counts. So with a 3 count versus a 2 count, we need to make an answer that has a 2 count. So 13.104 has to get rounded to the second position, which is the 3. We just round it to 13 and get out. But we're going to round at the end. Add and subtract, we round it at the beginning. Question about that? Here's what the next quiz looks like. We're reading 2.7, there's 3 new points, and then I ran this off for you because I suspected this might happen, and we don't have time to go like super duper detail. I think we can probably still squeeze out the metric thing. I think we have like 2 minutes, and I think we can squeeze out a metric score. Anybody need anything before I squeeze out a metric score? There is homework. The syllabus can give you the numbers. It's going to be primarily 5 to 10 with a little bit of 1H, 1I on it, but it's going to be like the packet we just did. It's going to be significant digit play. Can somebody hand me a metric and I'll do a grade because I don't have a copy of that. So metric, I got milli, M-I-L-L-I, that's 1,000th or 10 to the negative 3. Deci, D-E-C-I, that's 1/10, 10 to the negative 1. Micro, M-I-C-R-O, that's a millionth or 10 to the negative 6. Centa, C-E-N-T-I, that's a 1 over 100, 10 to the negative 2. Mega, M-E-G-A, that's a million, 6 zeros, 10 to the 6. Deca, D-E-C-A or D-E-K-A, I don't care. That's a 10. Nano, N-A-N-O, that is a billionth, 10 to the negative 9, 9 zeros in it. G-I-G-A, giga, is billion, 10 to the 9, 9 zeros in that. Hecto, H-E-C-T-O, is 100, 10 to the 2. Kilo, K-I-L-O, 1,000, 10 to the 3, whatever you like. If you spelled it wrong, it's wrong. There's no like half points on spelling. It's a point a box, so spell it funny and you don't get your point for that block.
What was giga?
G-I-G-A, giga, is a billion, which is 10 to the 9.
Where's it out?
It's out of 20.
If they put it in the wrong spot, but
Okay.
the number's right, like if the number
Then they-
matches the word, is it just -1?
Let's go -1 to be
Okay.
generous. Yes, that's a good way to score it. Question about scoring anything on that? Still have like 30 seconds to spare. Go us. So we'll get scores and run away. Still